So ice cream and freezers is a lot like apples and apple trees in that we're going to have interdependent classes that are going to be interacting with one another. And we want to make sure we're giving structure to more complex objects. So our case here is that we have I Heart Ice Cream. It's a creamery that makes delicious ice cream. They're growing rapidly and need some software to help them manage the kitchen. So our job is to build a program that will help manage their ice cream freezing. There are a few user stories to help get us started. So before, has anyone heard that phrase before, a user story? Yeah, what is a user story?
It's a way to describe how the system is going to be used, like what the user wants to accomplish, rather than being focused on the product. You're focused on the users of the product, and you're building a narrative around that.
Mm-hmm.
So as a clerk, I want to do X to have Y output. It should have this Y result, and then you design your program around the user stories.
Exactly, very well put. Excuse me. Yeah, so you're going to encounter this more often, especially when you do get to your own personal projects and final projects, is consider, all right, not just, okay, what technology you as a developer want to use, but consider, okay, what do I expect my users to be able to do? In this case, we have ice cream maker as our user. So as an ice cream maker, I want to make different types of ice cream, peanut butter, chocolate chip, etc. As an ice cream maker, I want to place batches of ice cream in a freezer. And as an ice cream maker, I want to know when a batch of ice cream is ready to be removed from the freezer. Okay, we can do that. Let's make sure we fork and clone it. Good point, Julian. Yeah, having our user stories like this also keeps users from trying to design technical solutions. If you find yourself doing freelance work and someone says, hey, I want to use this particular framework, and they're not someone in technology, ask them why they want to use that framework and more guide them towards, okay, what functionality do you actually want rather than what technology would you like to be using? And most users are pretty good. Most of your clients would be pretty good about that because most of them don't know this stuff, but you never know. So we take a look at what we have here. So it already has provided us with ice cream classes and freezer classes. And our spec file already has, the structure is already set up, but we don't have any code to test. So we need to know that we'll at least need the ice cream and freezer class. So maybe let's write some tests for that before we do anything else. So maybe we can do like test creates new ice cream. We could say, ice cream equals a new ice cream. And we know that it's going to be instantiated with a flavor, peanut butter, chocolate chip. So let's just say it's instantiated with vanilla. So we need to test that our ice cream is actually an ice cream object. Let's take a look at the unit test and see if there's anything that the unit test documentation, and see if there's anything that'll help us out with that particular thing. So basic example. Where are the matchers? Because we have a self true. Well, we can also do something like self.assert. Let's see what they have here. There's assert is. What does that do? Let's just Google that. So unit test assert is. Man, this thing does not want us to find out the difference. Find this, huh? Oh, that's interesting. So we have assert is instance. Test that object or is not an instance of a class. Hey, that sounds perfect. So we could say assert is instance. Ice cream is an ice cream object. So kind of a very, very simple class and test, almost kind of redundant, but hey, this is what we have to work with from what we know at this point. So for now, I'm going to say just put pass under these so at least they don't throw an error when we run it. And if I run green ice cream and freezers spec, if I remember how to do underscores. All right, we have an error saying ice cream takes no arguments. Okay, we can fix that. Great, our test passes. Our test that proves that ice cream is ice cream. All right, so not very much. So let's take a bit closer look at what we actually want to do besides just creating an ice cream class and a freezer class. Taking a look at the README, it says, think up this program critically before you even begin to write code and describe how you'd design this program in plain English. And we have to consider these questions. What are the essential classes? What attributes will each class have? What interface will each class provide? How will the classes interact with each other? And which classes will inherit from others, if any? Okay, so let's go back here. I jumped the gun a little bit. That's my bad. So let's first check this first question. Will we need other classes? Do we?
For the release 0, I would say no.
All right, so we can put, for tentative, we don't need other classes yet, at least. And let's talk about what attributes for ice cream. So we know they have a flavor. What else could ice cream have?
An amount of time it takes to freeze.
Yep, freezing time. And we take a look at the README here. If we jump ahead a little bit, there's also a status that is one of these things. So we can also give it a status about how frozen it is. All right, let's talk about attributes for freezers. What does a freezer need to keep track of?
It's capacity.
Yeah, we could have capacity. Should a freezer be able to track how many batches of ice cream are inside of it?
Yeah, it's contents.
Yep, you can call it contents or ice creams or batches, either way. Because remember, the idea...
Yeah, we had a little bit of discussion about that. I was working on this. Should you could track sort of the inventory by tracking the number of ice creams or the batches of ice creams, or you could track it as what's in the freezer. I guess any kind of, and to me it seems like sort of the default inventory should ride on the ice cream, and what freezer it's in is kind of sort of a descriptor. Any kind of thoughts on that? Like, you could do it either way. So any sort of best practice?
So I just want to make sure I'm understanding you correctly. So you're saying have the ice cream class keep track of the status of all the ice creams?
Right. Each batch of ice cream would have an attribute that says, here's where I am. I'm stored in freezer 2 or
Mhm.
shelf 3
So,
or
so an ice cream would keep track of which freezer it's in.
right.
All right, so that's actually, so under some circumstances, that would actually be the best practice, is to have the ice cream keep track of what freezer it's in. And we'll get more into that when we talk about ORMs, object relational mappers, and SQL. Because once we start working with SQL, we'll be able to say, all right, essentially each ice cream object would have like a freezer key pointing to a specific freezer object that we could then retrieve. However, since we aren't using SQL right now, the choice becomes, all right, if I want to see all of the ice creams in a freezer, and the ice cream is what keeps track of which freezer it's in, I would need to make methods to essentially look at every ice cream there is and find all of the ice creams that point to a particular freezer. So if we were using a SQL database, that would absolutely be the best solution. But since we're just using vanilla Python right now, that actually I think that adds more complication to this particular problem that we need. So your thinking there is correct is correct. It's just kind of in a different place. You know what I mean?
Okay, Roger.
I just wanted to clarify because it sounded like he was asking how exactly would you keep track, and I was trying to use that kind of law to meter concept of, the ice cream doesn't know anything else than what its flavor is. Well, I went one further and actually had each flavor was its own class inherited from the ice cream class. So that way each flavor has a variation of how long it takes to freeze. But so it doesn't know whether it's part of a batch, if it's sold. All it knows is it's ice cream and it takes this long to freeze. That's a concept I kind of went with it. But then I kept each ice cream object different types of ice cream object in a container class that I called batch. So I created a new batch class that kept track and it had functions to basically check the status of the ice creams that it contains if it's called upon. Otherwise, it doesn't necessarily call. And then each batch would actually be put on a shelf, which is like an index of the shelves that are in the freezer. And again, the freezer has capacity. I'm still kind of got a work in progress on it, but it's so the freezer has shelves. Each shelf can contain a batch. The batch can have anywhere no more than 12 ice creams. Otherwise it reaches capacity. And then I also have a ice cream maker class just to kind of simulate the guy, taking 15 minutes to a half hour to actually make the ice cream per batch and then putting it in the freezer, taking it out of the freezer.
Yep. So yeah, this is a very open-ended challenge by design. So there's no wrong design architecture here per se. So we could, because it mentions batches in the README, but it doesn't say what a batch is. So it's up to us to decide, all right, is a single ice cream object representative of a batch of ice cream, or is it not? And the question is, if we want it to be, it is. So let's say for now we just stick with ice creams and freezers, and then we can add more class functionality if we want to.
Is there something like an interface in Python, like in Java, you would say, class ice cream implements freezable? Is there anything like that in Python, or is there a way to do that in Python that's Pythonic, or is that just not something that Python does?
So you're talking about like modules?
No, it's I don't know if I can explain it well enough without a reference to Java having its pieces parts. But it's kind of like a class, but not really a class. It's an interface that other classes can take from and add methods. Like freezable would be one of those things. It's like an adjective.
Yeah. So I know Ruby has a very similar concept that they call modules. So it is kind of like a different way of inheriting almost. So essentially you'd say class ice cream would like extend the freezable module, and that would give it extra behaviors that can share with other things that can be frozen. I don't know off the top of my head if Python has an equivalent to that.
Are you trying to write are you trying to write like a base class that makes you implement methods,
Well,
Julian?
it's not a class.
It's similar. It has a similar structure to a class very often, and the idea is it's more of, it's kind of like saying this class I am now defining takes methods from this other structure.
Yeah.
But
Yeah, you're defining methods that have to be implemented, basically.
yeah, I suppose
Yeah,
so.
that would be an accurate.
'Cause I think the closest thing there is the ABC module in Python. ABC being abstract base class, and Python doesn't restrict you from writing the implementation. Like Java would restrict you from writing a body to that method.
Yeah.
Python doesn't restrict you. You could actually do it and then write an implementation. It's kind of an interface. It doesn't really restrict you. Yeah, but yeah, that's one of the modules you could use.
Yep, so that's definitely an option, but I'd say in this case, I think we can just stick to a normal ice cream class because we don't have other things that are freezable. So we don't have like a sorbet class and a sherbet class or anything like that. It's just ice cream for now. So taking a look at this, so for now we've got, all right, ice creams have a flavor, a freezing time, and a status. And then we could say, okay, how will classes talk to each other? All right, let's think about this. So assuming we just for now have an ice cream class and a freezer class, how do they interact with one another? And let's just not think about this in technical terms. Let's just put this in layman's terms. As thinking about our user stories here, if I'm a user interacting with the freezer, what should I be able to do with ice cream from freezer?
Put it in the freezer.
Yeah. So, ice cream can be put in freezer. What else?
But you can take it back out.
Yeah, ice cream can be removed from freezer.
The freezer needs to be able to increment the freeze time of the ice cream.
Yeah, so freezer can advance time. Don't know a better way to put that. And we aren't going to represent this in actual real time because that would take too long. So we'll just have like an abstract time variable of some kind that'll keep track of that for us. Anything else?
You might want to just have like a get status of the freezer, inventory monitor kind of thing.
Yeah, like maybe we want the freezer to be able to tell us all the status of all the ice creams within it. So freezer can show all ice cream statuses. Okay. Anything else, or do you think do people think we're okay to start for now?
So that kind of got to another sort of philosophical question of like here you are attributing the advancing of time to the freezer. Kind of in my mental math, it was more what seems more natural to me is sort of the outside calling program advances the math, advances time or whatever other things, and then and then interacts with the classes and the objects as a result of what's going on in the, I guess you'd call it the runner program. What do you? Because it seems, yeah. So basically, I guess if you reframe it that way, it would be freezer would react to time that is advanced elsewhere, and freezer would react to a request to show ice cream statuses.
Yeah, that's a valid concern, and yeah, it makes sense. My reasoning for having the advancing time thing be a function of the freezer is I want to make sure that I can test all of the functionality of ice creams and freezers on their own. I want them to stand on their own without necessarily having to rely on an outside runner file. So the more self-contained I can make these, the better. But in general, I might, in a different program, I may want to have some function that says, okay, advancing time may be a responsibility outside of that.
Okay, Roger.
All right, so now that we know attributes, we need to actually create that up. So ice cream is now initiated with a flavor and a freezing time. And we know that it's supposed to have a status from our README. And we take a look at the status. So it has to have at least these: watery, almost ready, ready, and freezer burned. So I'm going to assume that watery is probably the default status. But we're also going to need to keep track of all these other ones, right? So we could make that maybe a global, not a class variable, because this is the list of statuses. So we could do statuses equals watery, almost ready, ready, and freezer burnt. And the reason I'm making this a class variable is this isn't going to change, but it's going to remain constant for every ice cream. All right. And let's update our ice cream spec a bit. So in this case, maybe vanilla has a freezing time of 10. And what else do we want to test about ice cream objects? What other things are we going to want to know an ice cream can do?
It can freeze.
Mm-hmm. Yeah, so maybe we're going to have to make sure our ice cream has a way to advance its status from watery to almost ready to freezer burnt. It's like can advance statuses. So we make a new ice cream. And then maybe we'd want to run something like, ice cream dot freeze. And then we would say self dot assert equal. And we want to say ice cream dot status at that point should be almost ready, I believe is what we put there. So obviously this doesn't work yet. We haven't made this method, but now we have that. Now we can test that method. I'm going to put test ice cream can do that because this is specifically an ice cream test. Okay. Anything else an ice cream object needs to be able to do? Let me take a look at here. So thinking about things like, oh, yes?
It can go in the freezer and then be removed as well.
Mm-hmm. Yeah. And the question is, all right, so entering a freezer, should that be a freezer method or an ice cream method?
I'd say a freezer method because you're going to change your basically freezer inventory.
Yep. I would agree with that. So I'm going to say, so freezer can add ice cream. We can just copy this. And now that I'm seeing myself, do that again, I might have to do something like create a setup method and say self.ice_cream equals ice cream, vanilla, and 10. So that way I can just say, get rid of this and this, and just say self.ice_cream is an ice cream object. And then we should be able to say self.ice_cream status is that. So that just saves us a little bit of time further down the road. And we can make a new freezer while we're at it. I don't know if we're going to put any arguments to a freezer yet, so let's just say no for now. So maybe we want to say self.freezer. And we can call this method add ice cream. That would probably take our self.ice_cream as an argument. And then maybe we want to say self.assert in. I believe that's what we want to do. So we'd say we want to assert that self.ice_cream is in self.freezer.ice_creams. That's one way of doing it. All right, so let's take a look at some other functionality. So we also want to be able to remove from the freezer. So def test freezer can remove ice cream. Then we can kind of take it out and put it back in again, essentially. And then we'd say self.freezer.remove ice cream. And I guess that would be self. I bet there's a self-assert not in. Yep. Self.ice_cream and self.freezer.ice_creams. All right. What questions do you have about these tests that we're writing so far? Notice I haven't actually written most of the code to actually pass these tests yet. So, but I think for now, I'm going to start writing some of this code. I know we haven't done for every method we've planned to do, but this is for a few of them. So let's check this test ice cream can advance status.
Noah, can you go back up just to let me make sure I want to understand how you're using that setup again?
Mm-hmm. Yeah, so whenever setup is a function that runs before every test. And so what I'm saying is before you run each test, create a new ice cream object that we're going to be saving as ice cream, self.ice_cream, and create a new freezer object. And after every test, we're essentially overwriting that with a fresh new object. So we're not so it's not the same ice cream object every time, or it's not the same freezer object every time.
Right, so how are we invoking that then? Mm-hmm. Self-assert is instance.
Yeah, so setup it's a built-in method that we're calling. So that automatically runs. We don't need to invoke it ourselves. It automatically runs when we run our spec test. So we have 3 errors, but the objects aren't because we haven't had a freezer object. We don't have freezers or a freezer or an ice cream.
So it's automatically, just by virtue, it's automatically re-invoked for each test individually. You don't have to do it in front of each test.
Exactly. So it's shorthand for saying, essentially this is saying before each test, do this.
Right. Okay.
Okay, so let's take a look at, all right, we want to make sure that we can advance the thing. So we need to make a method called freeze. Take self as an argument. What did I just do? Okay. So in this case, thinking about that, in order to advance our status, we need to figure out what essentially where in this list our status is. So in that case, we're going to need to find the index number, right? You can say status index equals, this would be ice cream dot statuses, and we need to find out the index. So it'd be like, what's a method that allows us to find the index of a certain thing?
The enumerate, or well, if you're trying to loop through, then the enumerate. But if you're just trying to do find the initial index, index open close parentheses.
Yep. So we need to find the index of self.status. So if our status is watery, I expect status index to be 0. Almost ready, ready, freezer burnt. So I could say something like self.status now equals ice cream dot statuses status index +1. So all I'm doing is saying, okay, find out where I am here, give me the next one up. So I run my test, now I have 2 tests passing. Does anyone notice a potential vulnerability in my program though?
Once you get to freezer burnt, then
Expounds.
your SOL.
Exactly. I have an edge case here that's saying once I get to freezer burnt, if I run this function again, it'll break. It'll just say, hey, out of index, I can't give you that. So 0, 1, 2, 3. So we can say, just if self.status, not self.status, just status index is less than or equal to 3, or just less than 3. It can't be 3. So if that's the case, we advance the status. If not, we just leave it be. All right.
So in that case, so freeze is a method that is basically just advancing it one level. It's not taking it all the way to frozen.
Exactly. But the question is, we also have this freezing time thing. So how does that factor into it?
Makes it more complicated.
It does make it more complicated. So we have freeze, but we want to make sure that the rate of freezing is indicative of the freezing time somehow.
For me, oh, go ahead.
No, go ahead.
For me, I'd set up a dictionary, and I had to do it as a range. Well, I used a tuple to represent a range, beginning and end for timing. And again, I'm not sure how exactly you want to do steps, but what I would do is use that tuple as the range representation as a key, and then the value is actually going to be the statuses listed out in the list. So you can actually set some type of way to put in a range, and then now you're going to check if the current time or the duration that it's been in the freezer, if it's within that range, then it's still at this level. If it's in this next range, it's now almost done. If it's in this next range, it's ready to go. So you just test what the current time is in relation to like some type of range setup. So.
Yeah. That's one way of doing it. I was also wondering if maybe we could just say, like, come up with like a step amount that's based on the freezing time divided by our number of statuses, which would have to be which would, if we wanted to make this cruder, we'd maybe want to round it down a bit. So I could do something like self dot freeze increment equals freezing time, essentially that way. And then maybe we'd want something to keep track of not just our status, but also of our, like, where we are on the time frame. Maybe that self dot time starts out at 0. So yeah, I'm kind of spitballing here a little bit now, because then we'd want to be able to check, all right, if our
maybe is more is age, really.
Yeah, you can call it age. That's a good way of putting it. So if it increases by freezing increment, then it's.
I use percentages for thresholds based on the freezing time passed in. It's like, okay, if it's 95% of the way there, then it's almost ready.
Yeah.
That kind of stuff. That way it just scales with it.
Mm-hmm. Yeah, so we can also use percentages. That does sound a little bit easier. So I think we still need to keep track of self.age. So you do self.age plus equals 1. And then say something like, all right, so we'd have to say, all right, if it's under 25%, stay here. If it's between 25 and 50, it's here. If it's between 50 and 75, it's here. And between 75 and 100, it's here. Or maybe 33, 66, 100, and if it's above that, it's freezer burnt. Man, this one's a lot tougher than I thought. So we could say, percent done would equal self.age divided by freezing time, self.freezing time, and multiply that by 10. So if the age is 1, then we'd be at 10%. If the age is 2, we'd be at 20%, and so on and so on, assuming our freezing time is 10. And then we could say, all right, so this gets a little bit more tricky. So I'm going to comment out this for now. So I'm just going to do an eval statement because it seems like the simplest option right now, at least in terms of the way I'm thinking it, if not the most elegant. So if percent done is less than 33.3, self.status equals watery. Elif percent done is less than 66.6. Self.status equals almost ready. Elif percent done is less than 100. Self.status equals ready. Else self.status equals freezer burnt. So not quite as elegant as this solution, but it might work. We're going to have to revise our test a bit, though, because we're only aging it once, and we're going to want to freeze it enough so that it gets to almost ready. So I do just for blank in range. We want to freeze it 3 times. in that case, hopefully, that should get us to almost ready, I believe. All right, something broke. That's instructive. All right, let's take a look at.
That's not usually what I blurt out.
See, I always take errors as meaning, okay, something went wrong, which means I can fix it. I'm learning something here. Because if everything goes right, you don't learn very much. All right, so test ice cream can advance status. There we go. So watery does not equal almost ready. So in that case, it didn't advance the status the way we hoped. So let's do some printing here. I just want to do print %done, making sure I'm getting the values I think I'm going to be getting. Okay, so 1.0, 2.0, 3.0. So it looks like I just didn't age it enough. So if I age it 4 times, all right, still didn't work. Watery does not equal almost ready. So interesting. So even though it's 4.0, which should be greater than 33.3, but less than 66.6, it didn't update the status. So that's interesting.
I think for your %done, should it be times 100?
You're right. Thank you. I didn't. That totally went by me. There we go. Now we have 2 things passing. Perfect. All right. So we have a working solution. And I'm just going to take the win for now and then keep going. So ice creams can advance their status. Now we can focus on our freezer methods. A freezer should be able to add an ice cream. So that means we need to take a look at our freezer object. And we said in attributes it should have a maximum capacity and a number and a list of ice creams. So the question is, should every freezer start out with the same capacity, or should it be initialized upon, whenever you make an initialize one, you get to decide how much capacity a freezer has? It's up to us.
Oh, I passed in a capacity.
Yeah, might as well. And self.ice creams, or inventory, let's call it inventory, equals an empty list for now. Which means I'm going to have to update my test, say freezer has a capacity of 6, why not? All right, so then we can say def, what did we call it? Add ice cream. Add ice cream. Take self and an ice cream. And I think all we need to do is say if len of self.inventory is less than self.capacity, self.inventory.append ice cream. Does that make sense? Does it look good? Yeah, I think it makes sense. If I run the test, that should not make the test pass, as it turns out. What did I do wrong? What's it say? Freezer has no attribute ice creams. Oh, right. These need to match. Let's try it again. Now what? Yep, you need to be consistent. If you're not consistent, everything breaks. One more time. Seriously?
Line 30, self.inventory.
Oh, thank you. See, you got to be careful when you're just changing variable names willy-nilly. Otherwise, this happens. There we go. Another test passed. And then we can say def remove ice cream. And I'm assuming that in that case, we'll have to know what specific ice cream object we're looking for, right? So we may want to do something like, all right, if ice cream is in self.icecreams, because we may pass it something that isn't there. All right, and then we need to remove that specific ice cream from our self.icecreams. Is there a method that can just automatically do that for us? Probably, but what would it be? Self.remove looks like a good candidate. Let's take a look at how that works. Python remove. It removes the first matching element passed as an argument. So we could do, so hopefully it would just be self.remove ice cream.
I didn't get a chance to see. Does it have a side effect? Is it, shrink the list? Does it replace the, does it basically take that match out and then replace it in with a none, or is it just completely deleting it and shrinks down the list around it?
Yeah, we'll have to find out. All of our tests passed, but something may be wrong. So if I do, print self.freezer.icecreams, let's see, make sure that it's empty. So it came to an empty list. My other concern is that what if I add will it only add the ice cream remove the ice cream I told it to remove? So what I'm going to do is I'm going to add an additional caveat to this. I'm going to have freezer add a second ice cream. Let's say this one is chocolate with a freezing time of 20. Let's see if it only removes the ice cream we want it to remove. All right, so it looks like if the test passed, it didn't find self.ice cream there, but it looks like that this ice cream is still there. So I think that seemed to work out. Fingers crossed, and there aren't any side effects that we don't know about yet. All right, so our next one is the freezer can advance time. So we haven't written a spec file for that yet, so let's do that right now. So def test freezer can advance time. I'm going to say self.freezer.advance time. And maybe you want to say we can advance time however much we want. So we can advance time by 5 units. If that's the case, what do we expect to happen if we advance time 5 times? How will we know it worked?
Whatever's in the freezer should go to freezer burn.
Well, not necessarily freezer burnt. Depends on the freezing time, right?
Oh, yeah. Okay, right, yeah. So it's good. Okay.
But we should expect the statuses to change, at least, and the ages as well. So in order to do that, maybe we should write a method that can actually show us the status of every ice cream. So to do that, anyone would make a method first called show ice cream statuses. And maybe something like, for ice cream in self.icecreams. So we could just say print ice cream.status. Maybe that would work. But
you could return a string so you can test the string being returned and not have side effects.
I could also return ice cream.status. But in this case, again, I want to say, all right, I don't want my freezer class to necessarily be able to just directly access the ice cream status. Maybe I want the ice cream to be able to report its own thing. And so to do that, I'm going to add something cool to my ice cream. I'm going to add another dunder method besides init called str. Have we talked about str yet? I feel like maybe we have. No?
Yeah, we
I
talked
haven't
about it
seen it.
last week. It's what's printed when you call the print method.
Yeah, exactly. So right now, if I print out an ice cream object, it says ice cream.icecream 0xo. So I just wanted to print out the flavor and the status and the age. So that way I can just, look at everything in a nice, neat way. I'll return, flavor, self.flavor. Age, self.age, and status, self.status. So I guess in this case, I would have to print out ice cream, even though it doesn't let us test it, because then that's one way we can access the dunder method. Though I suppose we could also
Convert
return
it to a string, and that'll call the same dunder method. So it's
Yeah.
the string representation of the object, whether it's printed or cast to a string.
Yeah, so we could do str of ice cream. And so
Right,
whenever
but you want to do that after you build a string because you got it in a loop. So it's going to return only the first one, and it won't complete the loop.
Good point. So maybe I want to do something like for ice and ice creams. Yeah, just do like output equals that. Output plus equals str ice cream, return output. So we can also def test freezer can show ice cream status. Just say self.assert equal self.freezer.show ice cream statuses, and it should equal, now I have to look exactly how I formatted it, flavor, vanilla, age, 0, status, watery. I'm going to comment out this test for now because it's not ready yet. Okay, so, looks like that didn't work. We got bound method freezer.show ice cream stat 58 characters. Oh, I know what happened. I didn't actually call the function. Boop. So now if I actually call the function and run the test. All right, so in this case, we had an empty string. All right, let's see what we did wrong. Output equals an empty string. So I'm wondering if our str ice cream isn't working. So I print out str ice cream. What do we actually get? So it looks like that is the str thing did not work. So one thing we could also try, and this is not really best practice, I would say, but I actually want to make this work. I think I can actually just call on the str method directly. Or not.
I want to check and make sure your str method works because this is how I have mine done, and it's working.
Mm-hmm. Yeah.
Yeah, me, I use the repr function versus the str.
Mm-hmm. Yeah. So to test it out real quick, all I'm just going to do is print self.ice cream, because that should, in theory, show us that. All right, so it works when we print something. So maybe the problem is that it's an maybe it should be REPR instead of STR. And then we need to change this one from back to the STR instead of converting it into a string instead of calling on a string STR.
When you actually are calling the ice cream function, the repr function automatically will send it out. Basically, the repr, if you were to try to, let's say, print ice cream, it's going to turn that, it's going to call on the repr function. And in your repr function, you already have it as a string. So doing the string around it is just redundant.
So doing the string around mean this?
No, not in there. That's fine.
Oh.
Okay, so we'll go back
Gotcha.
in there. Yeah, that part there, because it's already, when you do the repr function, you're returning a string already. So now you're just restringing a string.
Mm-hmm. Yeah, well, looks like it's still not printing out ice cream the way I want it to. If I print out self.ice cream here, interesting that it works here, but I guess we can't just convert it into a string there. Man, this turned out to be a lot more complicated than I thought. I thought this would be a slam dunk. So I'm not entirely sure what's going on yet. I'm going to leave this function as it is, but I'm going to do this the old-fashioned way and essentially just copy this and put it here. Because at this point, I just want it to work. And just change all the s of self here to ice cream. Okay, now I'm just very confused.
Do we actually have anything inside of self.ice creams for it to loop through, or?
Oh my God, you're right, we don't.
Yeah, because if there's no objects in there, it's not even going to try to print the object. So
you are absolutely right. There we go. So this is a very instructive moment because this kind of stuff happens to literally every developer of every skill level you've ever met and will ever meet. It can be something that simple that we just don't see. So if you find yourself in a situation like this just now where it's like, wait a second, there's just some very basic thing I'm missing, that's why. So, all right, so we can show ice cream status. And the last thing I'm going to do before, because like, let's hear, we started how long ago? I think we've been out this almost an hour, right? So I'm going to just, let's see if we can get the advanced time method working. And then we'll finish for there for now. So I'm going to still do the test. Now I'll say self dot. I'm essentially going to just copy this test right here, but I expect it to be almost ready instead of watery. So now I can make a method called advanced time. Which we know takes a time argument. So we could just say something like, in this case, we need to call on our freeze method only advances by 1. So in this case, we're going to have to say for ice cream in self.ice creams, and then have a loop inside of that saying for in range time. ice cream dot freeze. Okay, interesting. So, oh, right, it shouldn't be age 0. It should be age 5. And then, all right. Okay, okay, now we're getting another issue where it's not returning the output again because I forgot to add it again. One day I will remember not to do that. There we go. All tests passing. All right, cool. So thanks for bearing with me as through that comedy of errors while I kind of bumbled through realizing that I didn't have any ice cream in my freezer. What questions do you have about what we've done? I want to emphasize that this isn't the correct solution. This is just a solution. So if you did something radically different, that's awesome. As long as you manage to get it working to your satisfaction, that's the most important thing. All right. So let's take a Tom, how long do you want to give him this time?
You give him a 10-minute break or till 10:20.
Yeah. So come back at 10:20, and then we're going to give it to Tom, and he's going to talk about CSV files.